So this is Geometry Semester 1. It's the unit called Congruence, and it's the unit number 7. Then it's the 5th lesson within that called HL, which is Hypotenuse Leg Congruence Postulate Practice. It's on creatormath.com under the Geometry tab. You may have to Google creatormath.weebly.com to find the site. The instructions are copy the following problems into your composition book on the correct pages according to the table of contents with the notes for those pages from creatormath.com. Let me slide this up. I'm going to get to these questions here in a second, but before I do, I always try to show you where those notes are on the website because it can be kind of hard to find if you sort of don't know where you're looking. Okay, let's try that. There we go. So, here it is here. It's creatormath.weebly.com. That's the website right here. Google it. You should get to this home page right here, if everything's working right. If you have any questions about your composition book, because my students are always asking, when is the composition book due? What goes in it? What goes where? All that stuff. Here are the instructions here. Scroll down until you see composition book. See the picture. Watch all the videos, you guys. Follow all the directions and the due dates, and you should have a 90 to 100% on that comp book, and the notes help you to do the problems like we're about to do right now. To do the notes, we want to go to the Geometry tab. Notes, videos, problem sets, and vocabulary is all under the Geometry tab. So if you're not getting 100% on your vocabulary practices, make sure you know how to open the Vocabulary Geometry Practice Study PDF. It's got all the vocabulary words for the entire school year, and it's searchable. Just Google how do I search a PDF with whatever device you have. It's slightly different with every device. I'm going to scroll down to the semester of this video. So this one says semester 1, that's the one for this video right here. It says table of contents. This goes on pages 2 through 6 of your composition book. If you haven't written all this table of contents into there, it's about 3.5 pages long, then stop what you're doing now and do it. Why? Because it's got all of the page numbers for the entire semester. Now you're going to know where to put all of the different notes that we take all the way through the semester. So let's go to the proper unit. This is the one on congruence. There it is right here. So here's the unit, congruence. It's got 1, 2, 3, 4, 5 lessons within it. This is lesson 5. We're right down here. So this is HL. That stands for Hypotenuse Leg Congruence Postulate. Here's the page numbers it goes on in your comp book. Here are the notes right here. We're going to click that tab in a second. Please don't take the page numbers from this video, but go back and find the original table of contents. At the time you're viewing this, these page numbers probably will have changed. So we're going to click Notes. We're going to open this. It might take twice to load. Sometimes it does for me. It opened the first time. You should be able to expand it. Now you're going to be able to take notes directly from your screen, right? So what does this one say? Given 2 right triangles with equal hypotenuse and 1 leg, what can be said about the 2 triangles? Well, there's a postulate that says that if the hypotenuse and the leg of 2 right triangles are equal length, then we can say that they are congruent. Again, congruency in geometry means that the 2 shapes are exactly the same shape and the same size. Right? That's what congruency means. So, and why don't we just say they're equal? Because it's multiple aspects of equality, is like I try to explain it. So it's not just 3 equals 3. It's, all the 3 angles of this triangle are equal to the corresponding 3 angles of this triangle, and all the 3 sides of this triangle are equal to the corresponding sides of this triangle. So it's multiple aspects of equality that allow 2 shapes to be congruent, or exactly the same shape and exactly the same size. This one's called Hypotenuse Leg Congruency Postulate. If 2 right triangles have equal length hypotenuse and 1 equal leg, they're congruent. Here's an example. Here's a hypotenuse of 10 and a leg of 5, hypotenuse of 10 and a leg of 5. They're congruent because they're right triangles, we can say, because of that HL congruency postulate. Here's another example. Here's right triangles, and we have a hypotenuse equal to a hypotenuse and a leg equal to a leg. They're congruent. And here's how you write it. Remember, this is the 5th lesson within congruency, so you should know a lot of these symbols. This is a congruency symbol right here. Let's make it a little better. There we go. Congruency is an equals with a squiggly over top, and this is a triangle ABC. And look, it's even a right triangle ABC is congruent to right triangle DEF. Let's see what the vocab is. Hypotenuse is the side not touching the 90-degree angle. It's also the longest side, and I hope you know that by now, but if not, we'll keep reviewing it, okay? Leg, one of the two, like a human. Yeah, so how many legs does a triangle have? Two, like a human, is what I try to say for you to hopefully remember it. And they're both attached or touching the right angle. Congruent triangles, equal angles and equal corresponding side lengths. Postulate, a rule or a definition. And a theorem, by the way, is something proven using postulates or definitions. So with those notes in your comp book, let's see what the problems are in this problem set. What does congruent mean? It means more than equal. Well, I would say multiple aspects of equality. Equal corresponding angles and equal corresponding side lengths, right? What does proportional mean? So every time we start talking about proportional, I bust out one of my model something. This is a model helicopter here. This one is, what's this one? This is a 1/48 scale dolphin in the U.S. Coast Guard color scheme. I have a couple in this scheme. I always show you the aerospatial. I don't know if I'm saying that right now. I got a couple of them here. And they're all pretty beat up, you guys, because they've been through the mill. But they've been test subjects for a long time. These are different types, and you can tell they're different types. Why? Because the small version looks exactly like the real version. So proportional, which means similar in geometry, means larger or smaller by a scale factor, but otherwise exactly the same shape. So there's no question in your mind what shape that is. It's exactly the same as the real, it's just smaller by a scale factor. All right, so what's the symbol for congruence? Is this one. It's an equals with a squiggly line over top. What's the symbol for similarity? This one here, it is a squiggly like that, says similar or proportional. Let's do this first problem here. The following shapes are congruent. Why? So we're going to rotate this one around here. If then F would rotate over to this angle, and E would be up here, and D would come down to here if we rotated the whole thing around. Then EF, so EF has 2 tick marks. DE has 1 tick mark, DE has 1 tick mark, and DF has 3. DF has 1, 2, 3. Does this side correspond to this one? Yes, and it's 1 tick mark. So the corresponding sides are the same length. The 2 tick marks correspond to the 2 here. They're the same length and corresponding sides, and the 3 to 3. This is a postulate called side, side, side. So we're going to mark this one here. We're going to say triangle ABC is congruent to triangle DEF because of the side, side, side congruency postulate. Okay? And we learned a new one today in today's 5th lesson. We learned HL. So these are some review of the prior ones that we learned in the prior lessons, and then we'll come up on HL. We should know these because we've done the prior lessons, all right? The following 2 shapes are congruent. Why? So I see a side, angle, side, and I see a side, angle, side. Notice the 1 tick mark, 2 tick mark, 2 tick mark, 1 tick mark, 2, and 2. So even though I haven't rotated this one, which I can, and then it'll be a lot more clearer to me that these are in order, I can also just go in order with my eye and see that this is side, angle, side. And I'm going to go a little bit faster only because it's our 5th lesson on this. We've done 4 other lessons. So they are congruent. Why? I see, let's see, I see an angle, angle, side. And notice it goes 1, 3, 8. 1, 3, 8. Angle, angle, side. So this is an angle, angle, side congruency postulate. Every time we can match up that in that order, we can use this reason to declare that yes, indeed, they are congruent. So in this case, we have angle, side, angle. Notice this side is included between the 2 angles. So do we have 1 tick mark over here? Yes. Then do we have the 5 and then the 2? Yes. And I know we could go backwards and forwards here, but if we can go in the same order, and it is the same order as this one, so we went this way. So we started with the 1, the 5, and the 2. Then we would start the same direction here, the 1, the 5, the 2, and 2 tick marks, that is, right? So this is going to be angle, side, angle. These 2 are definitely congruent. Why? Because of angle, side, angle congruency postulate. Here's how you write that these two triangles are congruent. So this is interesting. This is two triangles sharing a side. If it's sharing a side, this side must be the same as this one, right? They have to be. They're the same length. So what do we have here? We have a right triangle, right? The right triangle. And then we have a hypotenuse. So let's go through the sides of the triangle. This has to be the hypotenuse. Why? It's not touching the 90. So this hypotenuse is equal to the hypotenuse of this right triangle. So that's one of ours for HL. The other is a leg. So the legs are attached to the 90s, right? There's a 90 here too on this triangle. And since these share the same leg, they must be the same length. So this is a hypotenuse leg congruence postulate, and it only works with right triangles, right? So anytime you see a right triangle, and they're asking you, are these two right triangles congruent to each other? We're immediately going to think of the hypotenuse leg congruency postulate, because that's probably what they're using to prove that these are congruent. So same situation, now they're just saying, okay, given the same one that we already said is congruent, how do you write it? So if we go ADC in that order, ADC, then we're going to go in the same order here, BDC. So ADC, BDC. Triangle ADC is congruent to triangle BDC. Assuming they're congruent, which side corresponds to AD? Now we have this idea of corresponding. Corresponding is the same location but in a different triangle. So this location in this triangle, what is the matching location in this one? Got to be the hypotenuse out here. So I know one has been, the orientation's been changed, but that's okay. We can take this and flip it over in our mind and see that this side would be exactly in this position. So BD is corresponding to AD. Are these triangles congruent? Why? So I'm going to go in order here. I see an angle, a side, and an angle. We're going in this direction. So let's go in the same direction. They even put them in the same orientation. I'm going to go like this way. Is it 1, 1, 2, 1, 1, 2? Angle, side, angle. Yes, they are congruent because of angle, side, angle congruency postulate. Are these congruent? If so, why? So let's see which way. They're not even changing the orientation on us, you guys. So this is an angle, angle, side, right? AAS, and this is an angle, angle, side. So yes, these are congruent by angle, angle, side congruency postulate. Are these triangles congruent? If so, why? There, a little bit better. So these are right triangles. So we're going to go right for that hypotenuse leg. Are the hypotenuses the same length? Yes, one tick mark and one tick mark. And our legs, and they're attached right to the hypotenuse in this manner in the 90 in between the two. So they're the same leg. That is equal. So I can say HL, hypotenuse leg. If they had marked this one over here with two tick marks and put nothing here, we would have to say not enough information. But they didn't do that. They told us these two, which are corresponding sides, are equal, and they're legs. So hypotenuse leg fits in this case. Are these two triangles congruent? If so, why? So we have to know about vertical angles. Vertical angles say that this angle is equal to this one. Then we have to trace around. This is 6, angle 4. Now we're going to go over here. 6, angle 4. So side, angle, side is equal to corresponding parts side, angle, side. So yes, these are. Side, angle, side is our congruency postulate that proves it. What's the proper notation? So up here we said they're corresponding, right? Now let's just put it into notation. So if we're going to go ABC here, so we're starting here, we're going A, B, C. In that order, that's our first triangle ABC is congruent to. Come over here and do E, D, C. E, D, C. Triangle ABC is congruent to triangle E, D, C. We went in the same order. We went this way, boom, boom, went this way. And notice it flipped, right? The 6 was here, the 6 was here. It's almost like they've been twisted, right? But this shape is fun for geometry teachers because it proves that those vertical angles are equal. And that's another little piece of information that students are being sort of thrown a loop with, right? giving you one more piece to think about. Now we're assuming they're congruent. Which side corresponds to AB? This is AB here. This is ED here. So, and they went A to B, so we'll go E to D. ED. Corresponding means matching locations in different shapes. Excuse me. Are these triangles congruent? Okay, so here we have vertical angles again, right? Now we have a side, an angle, and a side. Do we also have a side, an angle, and a side? Yes, and they are the same length, the same measure, and the same length. So angle, side, angle, side, angle, side, thank you. Side, angle, side, yes, they're congruent. If we're going to write this, use the notation, we just prove that they are congruent. How do we write it? If we do ABC, so here we're going A, B, C. We went in that order. We're going to match that order. E, B, D. E, B, D. Match the order when you name the triangles. If we went ABC this way, then start out here on this one and go E, B, D in the same fashion they did to name the triangles. Now they're asking about corresponding sides. Which side corresponds to AB? Here's AB here. This one corresponds right here. 6 and 6, they're the corresponding locations on these two triangles, right? EB. Are these triangles congruent? If so, why? Well, it's a right triangle, so I'm going to think of HL right away. Do I know that these are the same? Yes, so these must be the same. Look, they're telling us these are the same, but here's the thing. HL uses hypotenuse leg. The hypotenuse is across from the 90, here and here. Do I know anything about this side and this side being equal to each other? So I don't know on this one. I can't use the HL. I'm going to say not enough information on this one, right? And I'm just following the HL strictly here. Oh, but I can. I see they're tricking me, all right? And I fell for the trick. The trick is this. If it's a 90-degree triangle, I'm looking for HL. But don't I have that this is the same length and this is the same thing? So I have side, angle, side of both, all right? Side, angle, side. There we go. Yes, they are congruent. I was testing myself and I finally passed. Are these triangles congruent? So now in this case, all we know is this angle and this leg. Okay, we know these two legs are equal to each other, but we don't know this or this. All right? So in other words, this could be like this. It could be drawn wrong. This could be out here. So there's not enough information to tell on this one. We can't use HL. We can't use hypotenuse leg because we don't know the hypotenuses. And we can't use side, angle, side like we did in the prior because we don't know this side here. Given the following parallelogram, are these triangles congruent? If so, why or why not? Well, they share this side. This side's the same. These angles, opposite angles, are equal in a parallelogram, right? Also in a parallelogram, this side's equal to this one, this side's equal to this one. So what do we have? We have side, side, side. We can prove that these are congruent through the side, side, side congruency postulate. Are these congruent? Okay, what is this? Are these triangles congruent? So this looks like a rectangle, right? Well, we know that this side is 1, 2, 3. So yeah, don't we have side, side, side again? Side, side, side. So we have yes. They are congruent through side, side, side congruency postulate. Are these triangles congruent? If so, why? Well, it looks like side, side, side to me, right? I see the three sides. I see a 1 and a 1. I see a 2 and a 2. And this could be flipped if they're not in the right order. If I go 1, 2, 3, and then I do 1, 2, 3, it doesn't matter which way you flip them. I can still get this side, side, side to match up. Are these congruent? Don't I have a side, angle, side? But let's look closer. it's one tick mark. No, angle, angle side. Sorry, I have an angle, angle side. I have a one tick mark, two tick mark, one. Do I have a 1, 2? I'm looking right here. Look, 1, 2, and right here. 1, 2, and right here. I don't know about this side, right? This is not angle, angle side because they're not the corresponding parts. So I have an angle, angle side here, but it's a different angle, angle side here. There is not enough information to tell. I can't use angle, angle side unless it's corresponding parts. It has to match up in the order. So if I went 1, 2, 1, I would have to know this one was a 1 tick mark here to match that one. Otherwise, not enough information to tell. All right, are these congruent? So I got a 1, 2, 3. No, they're not congruent. They're different lengths. This is 1, 2, 3. This is 4, 5, 6. No. No congruency postulate which applies. Okay? They're not congruent. Are these congruent? Well, let's see what I got. I got a 1 and a 2 and a 1 and a 2 tick marks. So this one's equal to this one. They're corresponding. This one's equal to this one. They're corresponding. But look, this one here is different. I need a side, side, side. So I don't have a congruency postulate that matches up. I cannot say these are congruent. In fact, it makes sense to me if this were 7, right? This would have to be wider here to accommodate the 7. They would not be exactly the same shape and size. They would not be congruent. Are these triangles congruent? So we have 1 tick mark and 1 tick mark. We have 32 and 33. These are different. And these two correspond. So if this were 33, this would be side, angle, side, corresponding to side, angle, side. It's not. They're different. So it's not single. Corresponding parts, angles, and sides have to match up and be equal, right? So no, there's no congruency postulate which applies. Okay. Are these triangles congruent? So here's a side corresponding to a side. Here's an angle corresponding to an angle, and a side corresponding to a side, and it's side, angle, side. Yes, side, angle, side. We do have a postulate called side, angle, side. They are congruent. All right, are these triangles congruent? Let's see here. So we've got a side corresponding to a side. We've got an angle corresponding to an angle, and a side corresponding to an angle. So side, angle, side. Yes, I think so. Side, angle, side. All right, make sure you're matching up the title of this video with the problem set you're doing. Here's the title again. This is Geometry Semester 1. It's the 7th unit called Congruence, and it's the 5th lesson called Hypotenuse Leg Congruence Postulate Practice. It's on creatormath.com under the Geometry tab, and hope this helps.